Yes, welcome back to Easy Gates TRB Polytechnic 2021 EEE Solutions. So let me go ahead with the 2 marks problems, and hope you have seen the contents already delivered for electrical students, and around 4 to 5 problems of 2 marks already done. Okay, hope you have seen the solutions. Okay, let me try to offer little more clarity on the problems already I have discussed. Especially 2 problems, one from the circuit and another one from control systems. Okay, so that we can have a different perception. So that will help us in future. Suppose if you face such a problem, there is some helping hand by the designer. Okay, in every problem there was a helping hand. If we feel that helping hand, we can try a different route so that we can try to complete the problem in less time. That is a plan. Okay, so even though I have offered you the solution is not going to change, but how quickly you're going to get that solution, how quickly you reach that destination will be little different. Okay, this is little logical, so that logic you can exploit. For example, in one problem in control system block diagram representation problem, I have taken 3 routes. Okay, so out of the 3 routes, even I felt the block diagram was quicker comparing to SFG route and common sense route. Okay, so this is how you can strategize okay, your plan, okay, before beginning a problem actually. Okay, so you have to plan the route before you begin the problem. So once you get stuck in the middle and then you change the route, means already the time is lost. But a little extra things, whatever you have done, will definitely will help you in the next route also. But we are not sure. Okay, so that's why. Okay, you have a clear-cut plan before you begin the problem. Okay, based on the given data. Okay, so we'll fine-tune that little so that you'll have a different perception of the same problem and you try to solve it as early as possible. Okay, so I'm revisiting 2 problems first before getting into the next 2. Yes, this is the first problem. Okay, I'd like to revisit once again. The solution is not going to change, but the route. Okay, but still, let me go ahead without the solution. Same circuit. Okay, one voltage source V and current passing through the resistor I1. Take capital I. Okay, this is I. Okay, this is I1. And this is A times I1. A is given anyway, it's 2, that's 2 times I1. Okay, same circuit, but what he is saying is connecting a resistor in parallel with the voltage source means you can happily connect it once again between the 2 terminals. This is where I can connect the resistor called Rx, and this is variable between 0 and 0.99 R. Okay, so now let us have a perception. Now itself, here itself we can have the perception, then we'll play. So Rx is adjusted such that the voltage source delivers minimum power. Rx is adjusted. So that's the only variable in the circuit. We are going to adjust this. Okay, now let us play with this. So we'll go for the 2 extremes. We'll see what is going to happen for the current. Okay, so once you get familiar with the circuit, and definitely you will feel you're going to get a better route. Okay. So let me have a copy of this. Let me force the 2 condition. We'll see where the minimum power can be delivered by the source. We'll see that. Say for example, first I'm forcing Rx is equal to 0 ohms and taking the reference as 0, for example, then since Rx is 0, the top potential will be equal to 0. Okay, Rx cannot be 0 in fact, because you'll be shorting out your source. Okay, under this situation, okay, assuming this is still okay, so Rx is closer to 0 at least, means it's almost a short, this is almost equal to 0, so still you can allow, okay, almost 0. Okay, so almost 0 means then what is the current it is going to supply? This is going to supply only almost 0 current. It is going to supply almost 0 current, then this is going to be A into I1, and this is going to have the current equal to 0 amps. So this is 0, this is 0. Okay, Then what is the current I then? Okay, so then for the argument's sake, this current is 0, this current is 0. Okay, so what will be the currents? And Rx is very closer to 0 means, and it's almost like a short. This is a potential closer to 0 because of this wave only. But still assuming this is the potential V. Okay, this is the potential V instead of a perfect short, assuming Rx closer to 0. So this is V. Yes, then this current is going to be V by R. Let me take that way. This is going to be V by R. If that is the case, this current is going to be 2 times V by R. Okay, assuming your Rx is closer to 0. So this is 2 V by R. This is V by R. Then, so what will be the KCL at this? Okay, so what does the KCL means? And this voltage is V. Okay, so then this current will be V divided by, that's a huge current. It is going to be a huge current because assuming V is still there and assuming its Rx is something around, for example, you can take R is equal to 100 ohms. Then comparatively your Rx is very, very small, say for example 0.1 ohms. And let this battery is for example around 10 volt, then the top potential will be 10 volt for understanding purpose. And this is also going to be 10 volt and 10 volt across 100 ohm. This will be around 10 by 100 means it's going to be around 0.1 amps, and this is going to be 2 times 0.1, it's going to be a 0.2 amps. So 0.1 it is taking and 0.2 it is taking. So still I'm maintaining 10 volt for a reasonable better analysis, assuming this is a 0.1 ohm for analysis sake. Then 10 volt across 0.1 will make a current of 10 across 0.1. Okay, will make a current of 10 by 0.1, that is nothing but around 100 amps. So this is going to draw a current of 100 amps. And what is the current coming up? 0.2. And what is the current it is taking? So the 0.2 it is supplying, not 0. Take this way. So it's 0.2 is the current coming, 100 it is taking. So therefore this current is going to be 99.8. So this is 99.8 because this is supplying 0.2, this supplying has to supply 99.8. So therefore the current is going to be 100. If that is the case, so this is 99.8 and what is this current? 0.1. If that is the case, it has to supply how much current? 99.9 amps current. In that case, it is going to deliver a maximum power. It is going to deliver a maximum power. Okay, right? So the power is going to be maximum. So let us take some other situation with the same data. We'll see what is going to happen. Yeah, that's how we can conclude. Okay, where it is maximum, where it is minimum. Okay, so now I'm taking the same 10 volt and let R is already taken as how much? 100 ohms. So then I'm going for Rx is equal to 99 R maximum. Okay, closer to that. So not even 100, 99 R I'm taking. So if it is 99 R means it's going to be 99 ohms. So then still this is 10 volt means taking the bottom rail as 0. So again this potential is going to be 10 volt. So the current remains constant. This is 0.1 because I'm maintaining the voltage constant, and this current will be equal to what? 0.1 into 2, that is going to be 0.2 amps. Okay, so now anyway 10 volt is going to fall across this 99 ohm. So 10 across 99 approximately, 10 across 99. In this case it is going to be 10 by 100 approximately, slightly more than that. Okay, so 10 by 99, I can say it is 10 by 99 will be, so slightly more than, exactly if I calculate 10 by 99 for a name's sake. Okay, I'll take the number so that I will prove it. That's how we need to get convinced in the examination. So 10 by 99 exactly will be this number. Okay, we can play analytically. It's going to be 0.101. Let me take. So this current is 0.101. Exactly, it is 0.101. So this current is going to be 0.101. Okay, so this is 0.101 and this is 0.2 means what should be this current? Okay, so it is 0.2, 0.200. You're subtracting 0.101 from this, then it is going to be 0.099 will be the current. So this will be 0.099 amps. So 0.099 amps is the leaving current. And what about this current? It is going to be a 0.1 current. Okay, 1 minute. Let me check. This is, yes, that's a mistake I'm committing. So yes, this is the current. Okay, so 0.2 minus 0.101 current is in this direction. So this current is contributing out of 0.1, this is contributing this much. So what is the remaining current? That should be this. So that means it's 0.100, then 0.099 means you will end up with 0.001 amps will be this current. So this current is going to be 0.001 amps. So this is the current now when R is 99. So see the situations. Okay, so first situation, it is delivering a current of 99.9 amps. Now the situation delivering a current of 0.001. Therefore, this is the minimum power situation. So the interesting conclusion is this. So first, because we have a problem, find the value of Rx such that, okay, the voltage source delivers minimum power means it's possible only when Rx is equal to 0.99 R. And the designer is actually helping us by giving, see the options. When you see the options, option A is having 0.99 R as your Rx, and option B is also having 0.99 R as your Rx. Okay, then see option C and D, and he said Rx is going to take a value only between 0 and 0.99 R. In fact, he himself is violating this condition. He's going for a different values above the range means automatically they have to be discarded. That is the helping hand he is offering. Okay, whether you really play with the logic or you read it from the multiple choices given means, then it's better route. See, interestingly, how he is offering helping hand. So he is having option A 0.99 R, option B also 0.99 R. So he is forcing us strictly go for that value. That's a very indirect information is conveyed. Okay, so therefore that should be the data. Okay, where the power is going to be minimum. So set the problem at this point. Okay, so then because we are looking for that particular point where the power will be minimum. So he indirectly supplied the data, so set the problem only there. Okay, namesake, he asked to find the value of Rx. He has given such a wonderful clue with that you can build, okay, easily. Okay, now then you can approach the problem. Then the route is going to be same way. Okay, so then how it goes, we'll have a quick conclusion. So what we have after choosing Rx is equal to 0.99 R, then the route is same. Okay, what is that route? So we have a voltage V, then we have the resistor R, then we have a dependent current source, then we have the resistance Rx. Rx is 0.99 times R, and this current is 2 times I1. So taking the bottom rail as a reference, so this is 0 volt and this will be V. Okay, so this point is going to be V, this point is going to be V, and this point is also going to be V. Okay, then recently we did, so it's going to be V by 0.99 times your R. So it is nothing but 1 by 0.99 because the voltage across this is going to be V. So 1 by 0.99 times V by R, 1 by 0.99 recently we have evaluated, it's going to be 1 by, recently we did 1 by 99. Okay, 10 by 99 we got 0.101 means what will be 1 by 99? It is 0.0101, like that we will get. So it's going to be 0.0101 times V by R. Okay, that will be okay. So let me have a small check. 1 by, it is 10 by 99 is nothing but 10 by 99. 10 by 99 is 0.101. Okay, almost 0.1 and 1 by 100. So it's 0.101. So now what I'm getting is 1 by 0.99. What is the link between the two? 1 means divide by 10. So divide by 10 means what will get 9.9, right? So it's going to be, yes, we should not. Okay, so then we have to check 1 by 0.99 is almost equal to the one only, right? So therefore it has to be 1.01. That should be the data. A small mistake. Yes, should be more than 1, right? Yes. 1.01 times V by R. Okay, so let me take this. Yes, if it is an integer, it's very easy. Since it's not given as a round number, then we have this problem. Okay, so that's a current. So this current is known as 1.01 times your V by R. Okay, that's your current. Then what is this current? This current is I. What is that current? I is V by R. And what about this current then? It's 2 times V by R. So what is the current coming here? 2 times V by R. So what should be this current? So this current is more comparing to this. So this current is going to be 0.99 times V by R, because 2 V by R is coming. From that you are losing 1.01. So it's 0.99. So this is V by R and this is 0.99. So it has to be 0.01 times V by R. Okay, that's what you're getting. So then what you need to find? You need to find the power delivered by the source. Okay. Check once any mistake committed. So we are going to find the power. Some approximation we have done somewhere. 1 by 0.99. Yes, 1.01, like that it goes on. Okay, fine then. Okay, so let it be. So then finally, what is the power delivered? The power delivered will be equal to V, that's a minimum power, V into the I, that is going to be 0.01 times V by R. So approximately it is 0.01 times V square by R. Okay, so nothing but 1 by 100 times V square by R. Okay, in the earlier route we got accurately 1 by 99 times V square by R. In this case we are getting 1 by 100. Okay, somewhere we made some approximation, but still we're getting the same answer. Yes, option is A again. Okay, fine. So that's one fine tuning for our perception. Okay, we'll have one more little fine tuning of the fundamental. Yes, that's a control system problem. We did it by RH method, Raoult's criteria. So how to make quickly, how to answer this problem quickly means, yes, again, you have to get the helping hand from the options. Last problem, you have to get the helping hand from the options given. And similarly, here also you have to get the helping hand from the options. How to get it, we'll see. So again, form the characteristic equation. 1 plus g of s h of s equal to 0. You'll end up with 1 plus 10 by s into s plus 2 into s plus k equal to 0. Okay. So then you will end up with s into s square plus 2 plus k into s plus 2k. 2k plus 10 equal to 0. We'll end up with s cube plus 2 plus k into s square plus 2k into s plus 10 equal to 0. That's your characteristic equation. Okay, then hereafter we have to play only with the RH criteria. We'll see how quickly we can do it. So first row will be filled by coefficients of the characteristic equation s cube, s square, s power 1, s power 0 we have. Okay, then what is the first row? 1 and 2k. So first row will be 1 and 2k. So if we want, you can have 0 as well. Second row will be 2 plus k and then 10. 2 plus k and then 10. Okay. So then this is 0. So then what we get here is 2 plus k into 2k minus 10 divided by 2 plus k we are getting. Okay, this will be 0. This will be 0 by fundamental. If we take this as some x, then x into 10 minus 0 divided by x, this will be 10. So then remove this x. This is what the first column elements. For stability, what is the condition? There should not be any sign change in the first column elements. So then what is the first condition? The 2 plus k should be positive, because this is positive. This is positive and there is no sign change means, so they have to follow the same sign, this element and this element. Okay, so of the first column have to follow the same sign, therefore it must be positive, this must be also be positive. So 2 plus k positive means it is giving the first condition. So 2 plus k greater than 0 is the first condition, giving k greater than -2. We know that. So when you substitute k is equal to -2 in this, k greater than -2, you substitute k greater than -2, it says it is stable. Okay, so k equal to 0, for example, this will be positive. Suppose if I let k is equal to 0 in the second term, then k is equal to 0 means this is 2. 2 into 0 is what? 0. 0 minus 10, it's minus 10. So that means it is going to be plus, it is going to be plus, it is going to be minus, it is going to be plus, means there are two sign changes. System is still unstable for k equal to 0. Now play with the trial and error route. So definitely k equal to 0 itself, system is unstable. Therefore, definitely -2 is not the condition. Okay, because k between 0 and -0 itself, it is unstable. So this is not the right statement. So k greater than 0 means we can try. K greater than 0 means, because k equal to 0 itself, okay, it is not working, means then this is wrong. So we have to check k greater than 0. We'll check k greater than 0 means k is equal to 1. Let me substitute. If we substitute k is equal to 1, what is this factor? It is going to be 2 plus 1 into 2 into 1. Okay, right? 2 into 1. Okay, so minus 10. And check this value. It is 3 into 2, that is 6. 6 minus 10 is definitely a negative number. It is less than 0. So it's not positive. Therefore, again, you will get the sign change even for k equal to 1. So then let me try for exactly k is equal to the 1.45. If it becomes 0, that is the answer. Already we eliminated. Yes, k greater than 0 also we eliminated. Therefore, this is the only choice. So we can happily say k greater than 1.45. The system is absolutely stable. Yes, this is the another way we have to approach the problem. If you go by the actual method, we are time trapped. Okay, right? Yes, such a time trap we need to avoid in the exam. So this is what you need to try first. If this is not working, then you go for the actual route. Okay, so try logically, you can save time in the examination. Okay, that's a point. Okay, so first route, you may be going with the fundamental. So after very good practice, this is how you need to strategize, okay, for every problem. So you need to make a strategy first. You have to chalk out a plan and then execute that plan and try to complete the problem as early as possible. Okay, so that's a reason why I'm revisiting these problems. Okay, so last time it has taken more time. This is how the problem has to be approached so that the solution is very instant. Okay, right? So even you can try a value for k is equal to 1.45. It's not going to be very easy. You try for k is equal to 2. Then if you try k is equal to 2, then it is going to become 4. 2 plus k is 4. Then 2k into, that is 2k means it's going to be 4. So 4 into 4 is going to be 16. 16 minus 10 in that case. So that means you are able to prove that k is equal to 2, making your system what? Stable. Then you try for k is equal to 1.5. If you try 1.5, then it is 3.5 into 2 into 1.5 will be 3. So 3.5 into 3 will become, it is going to be 9. So it's going to become 10.5. Yes, 1.5 itself system is approaching stability. Therefore, a better number. Okay, so all are, this is negative, this is negative, this is greater than 0. Therefore, the best choice is this. Okay, like that frees your problem. Okay, that's a way, a small fine tuning for the last problem. These are all the 2 marks, and you should not get time trapped. You should not struggle for the idea. Okay, so there is a helping hand given by the designer. Always exploit that helping hand. Okay, hope this video helps you to understand things, okay, better and play smartly, okay, during the examination. Okay, that's the reason why again I'm revisiting the last 2 problems. Okay, so thanks for watching. So you can, even you are free to suggest. Okay, so if I go by a different route, it may be, you may feel little lengthy, but still you can suggest your own routes. That you are most welcome to feed your suggestions. Okay, right? And if you want more clarity on some fundamentals, still, okay, you can ask for. Okay, and since most of the aspirants are already prepared the content, probably you are on track with the fundamental. Okay, and hope you follow instantly. Even if I little go down, you still you catch that point, I hope. Okay, so thanks for watching and do subscribe our channel. Okay, we'll meet you with one more video. Okay, yes, thank you.